Good day everyone. For problem 6.3, we are asked to derive the equation of the elastic curve of the cantilever beam subjected to a triangular distributed load that varies linearly from 0 to W sub 0. Since the load increases linearly along the beam length, we first express the load intensity as a function of x. W times x is equals to W sub 0 over L times x. This equation means that at x is equals to 0, the load is 0, and at x is equals to L, the load becomes W sub 0. Next, we use the differential equation of the elastic curve. EI times d raised to 4 times y over dx raised to 4 is equals to W times x. Substituting the load function into the beam equation gives EI times d raised to 4 times y over dx raised to 4 is equals to W sub 0 over x times x. Now we integrate the equation once again to obtain the shear equation. EI d raised to 3 times y over dx raised to 3 is equals to W sub 0 times x squared over 2L plus C1. To solve for C1, we apply the boundary condition at the free end of the cantilever beam where the shear force is 0. At x is equals to L, therefore 0 is equals to W sub 0 is times L squared over 2L plus C1. So C1 is equals to W sub 0 times L over 2. Next, we integrate again to obtain the bending moment equation. EI times d raised to 2 times y over dx squared is equals to W sub 0 times x cubed over 6L minus W sub 0 times Lx over 2 plus C2. At the free end of the beam, the bending moment is also 0, so at x is equals to L, therefore 0 is equals to W sub 0 times L squared over 6 minus W sub 0 times L squared over 2 plus C2. Solving for C2, C2 is equals to W sub 0 L squared over 3. Now we integrate once more to get the slope equation. EI times dy over dx equals to W sub 0 times x raised to 4 over 24L minus W sub 0 times Lx squared over 4 plus W sub 0 times L squared x over 3 plus C3. At the fixed end of the cantilever beam, the slope is 0. So at x equals to 0, therefore dy over dx is equals to 0, hence C3 is equals to 0. Integrating again gives the deflection equation. ELy is equals to W sub 0 x raised to 5 over 120L minus W sub 0 Lx cubed over 12 plus W sub 0 times L squared x times x squared over 6 plus C4. At the fixed end, the deflection is 0. So at x is equals to 0, therefore y is equals to 0. Therefore, C4 is equals to 0. Finally, the equation of the elastic curve is y times x equals to W sub 0 over EI times x raised to 5 over 120L minus Lx cubed over 12 plus Lx squared times x squared over 6. This equation represents the deflection of the cantilever beam subjected to a triangular distributed load. Thank you.